Okay, this is last chapter in the last title in chapter 8. It is about interactions between independent variables. So this is third case how you can develop nonlinear models. Interaction is actually having the following explanation. It is if you have some independent variables, but also interaction of these two variables, like here, is very important for influence on the dependent variable. For example, if influence of x1 on yi is dependent upon the influence of x2 on x1. Therefore, you can implement interaction term, but it doesn't mean that you cannot have some more variables here, like for example x4 or x5, or even to have interaction of higher rank with x1 times x2 times x3, for example. There are three different cases of interactions. First is if you have the interaction of two binary dummy variables, those that have only two values, 0 and 1 usually. The second one, this is the interaction between continuous and binary variable. And third one, if you have the interaction between two continuous variables. So let's go to the first case, interaction between two binary or dummy variables. We'll mark them with the D1 and D2. And for example, this will be earnings, logarithm of earnings. This will be college degree, and this will be gender. So college degree has two values, 0 and 1. One if someone has college degree, and D1 will be gender. Actually, 1 if it's female, 0 if it's otherwise. And if we know from theory or from real life that actually the earnings, if it is depend upon the college degree, also depend on the female. The females and males, for example, with the college degree don't have the same incomes because there is a gender pay gap. So we want to see what if effect of degree on earnings depends upon gender. So this means that we will develop the model with interaction D1 times D2, and now we have beta 3 new estimate, new coefficient in our equation. So it actually means the changes in y on value of D1 depends upon the value of D2. So changes of income upon the value of someone with a college degree depend upon his gender. On the other side, also, if someone doesn't have degree, also it depends upon his gender what will be his income. When we develop the equation and solved it, we will get the following. So changes in y will depend upon the beta 1 and beta 3 coefficients and depend upon the value of D2, depend upon the value of the gender. The model actually allows for a difference if D2 is 1, if it is a female, then changes in y, changes in income will depend upon the values of coefficients beta 1 and beta 3. If it's otherwise, then changes in y will depend upon only the value of beta 1 because D2 will be then 0. So we will lose beta 3 coefficient. This is very important when you are making a comment on these values. The next case is when we have interaction between continuous and a binary variable. So for example, we have earnings again. We have years of work experience. This is continuous variables expressed in age, in years. And we have college degree as a dummy variable. 1 if someone has a college degree, 0 if he doesn't have a college degree. So in this model, the effect of additional year of experience on earnings is the same for college graduates and non-college graduates. If we don't have multicollinearity, we will get the same value. But we want to see if it's depending upon whether someone has a diploma or not. So we will put the interaction term xi times di in our equation. So this model allows for different slopes and different intercepts. If d is equal 1, then expected value for y will be beta 0 plus beta 1 xi, if someone doesn't have a degree. If someone has a degree, so the expected value of dependent variable will be this term here. So we can get different kinds of slope depending upon the values of our variables. So with the different intercepts or with the same intercepts and with the same or different slopes. It depends upon the value of our variables. Okay, the third case, interaction between two continuous variables. So model with interaction means that we have the interaction also between x1 and x2. Again, we have earnings. This is years of work experience. This is the years of schooling. And we know that years of experience will influence on the earnings depend upon the years of schooling. If someone has more years of schooling, his experience will give them more money in comparison with someone who has less years of schooling, less years of education. So this will be change in y due to change in x, but it is influenced by x2. So the effect of age on earnings depends upon the years of schooling. Change in y due to change in x2 will be the opposite. So the effect of schooling on earnings will depend upon the years of experience. Okay, let's develop the model. In our case, we will use test scores, student-teacher ratio, and expenditure by students. So meaning that actually student-teacher ratio is also influenced by expenditure per student in certain districts, because if you invest more money, then you can reduce the student-teacher ratio. Okay, let's go to the example. These are our data. Test score, student-teacher ratio, expenditure per student, but we need to develop a new variable that will be interaction. So add, we'll define new variable. I will call it interaction, just equals to student-teacher ratio times expenditure per student. Okay, and here it is. So let's develop a model, ordinary least squares, test scores goes up, student-teacher ratio, expenditure, and interaction. Okay, and here it is. Interaction is also statistically significant, so it is obvious that we have that influence. So in the combination of beta coefficients, we can express the influence of the changes in test scores for the change of student-teacher ratio under the influence of the expenditure. This is the end of presentation.